matrix? What shape does it look like?
A whole bunch of green characters going down the screen.
A whole bunch of characters going down. Okay, so it could be a square, or it could be a rectangle. So a matrix is a rectangular arrangement. Of numbers. Sometimes it could be a square, like a 2, if I had 4, or a 2 by 2 matrix, or a 3 by 3 with 9 numbers in it. And they are organized in rows and columns. So a matrix, when you read it, you start at the top left, you read all across the row, and then you go underneath. I don't know where the stapler was. Oh, it's on it, this does. So when you read a matrix, you go across the row, and then you go underneath to the second row, and you move across. So a matrix might be something that looks like this. So dimensions, if you are given like the dimensions of a room or the dimensions of a pool, what are the dimensions describing? Jake?
What space it takes up.
Yeah, what space it takes up or the size of it. So the dimensions would be the size of the matrix. So how big is the matrix? How big is the room? And with a matrix, we go with the number of rows. And then we use a little X, which really means the word by. And then the number of columns. Which way does a row go? Sean? Left and right. So my rows go left and right. A column is like the Colosseum, those pillars that hold up the Colosseum, or if you have pillars on your front porch, they hold up your front porch. So columns go up and down, rows go left and right. So here are my rows, and then these are my columns. What are the dimensions of this matrix that I have drawn up here? Chris?
2 by
2 by what?
3.
3. So there are 2 rows. I'm going across twice and down 3 times. So the dimensions would be 2 by 3. So this doesn't mean I'm multiplying 2 and 3 together. That's just the way you give dimensions when you're measuring something. The last word is an element. What's an element? Not in science, so not a chemistry element. What's an element? Julia, do you know what an element is? No. Chris? What letter? All of them? So each letter in my matrix over there is an element. So one of them is an element. So like the letter A is an element in the matrix. It's in the first row in the first column. So you will see each element labeled with a position. So A would have position 1, 1, because it's the first row in the first column. So if I had E, E would have position 2, 2, because it's in the second row of the second column. So you might be asked to locate where a specific number is, or a specific letter would be, depending what you have up in the problem. But they are notated as subscripts, and like it tells you the row and then the column. And it's always row, column. Questions? So today we're going to do easy stuff with matrices. Not a lot of work, not a lot of thinking, because we're just adding, subtracting, or multiplying with a scalar. to add and subtract in these matrices, I don't know why some of my matrices printed with gaps in them and some of them printed okay. I don't really know why. So these should have all little lines. So when you add or subtract matrices, simply add or subtract the corresponding elements. You can add or subtract matrices only if they have the same what? Jake? David? Number of rows or columns or dimensions. So I can only add or subtract matrices if they have the same number of rows and the same number of columns. And then literally you're taking the corresponding elements and adding them together. You're not going to be physically showing this work. That's what you're just doing in your head. So they just have to match up from one matrix to the next. So if you look at the first two examples, add or subtract the matrices. Letter A, we have 6, -2, 1, 3. You're subtracting 3, 2. So Julia, what would we find? How do we find that solution?
You can't because they have different dimensions.
Right, so here we can't find the solution. Julia, what is the dimension of the first matrix?
It's 2 by 2,
2 by 2, and the second one is?
2 by 1.
Good. So 2 rows, but only 1 column. They're not the same. You cannot subtract them. Make sure they're the same first before you do the subtraction. So then the second one, you're literally just adding the 6 numbers in the first matrix with the 6 in the second matrix. So learn -1, 2, and 1 is
-1.
good, and then the one on the right
-3.
underneath.
-2, 12, 8, 11.
Questions? So you're adding the matching elements from one to the next. Or I'd subtract. The next thing underneath this is multiplying by a scalar. The scalar is kind of like a coefficient or constant number, except it's in front of a matrix, so it gets a special name. But it's just the number sitting in front. So you could think of distributing that number to everything that sits in front, multiplying that number by every piece in the matrix, but that 2, -2, is just affecting each element inside that matrix. So, Kyle, when you multiply by -2, what do you get? Good. So if you look at letter B, see, remembering order of operations, try and simplify that matrix. So Amanda, what would you do first? Why do you multiply before adding them? Yeah, order of operations says multiplication first before addition or subtraction, so that works the same way with matrices. So what did you get when you added them, Amanda? Or, I'm sorry, how about when you multiplied?
I got -8.
And then when we add them together, what's the final answer?
-11, -24, 26.
Good. Does anyone have questions? Hopefully fairly straightforward. So at the top of the next page, I think is the only interesting problem really that might get you to think a little bit. This is a matrix equation. It looks exactly like equation form as if I have like mx plus b. So So you have two matrices that are being added together. Each matrix has a variable in it. The first one has an x, the second one has a y. There's an equal sign, and there's a matrix on the other side. Plus there's a 3 grouping those matrices on the left together. But our goal is to get x and y. So the x and the y in the matrix, that's our goal is to like solve for those. So see if you can think of how you would go about solving, finding the x and the y. There's multiple ways you can start the problem. So there's not one right way to start. There's a couple of different things that you could do. Abby, what's one thing you could do to start solving this? Yeah, so generally when you have things inside the parentheses, so you're adding and subtracting them, you can combine those together. So what did you get when you combine the terms inside the parentheses?
I got 15x, negative 14, negative 3, and 41.
I think you may have multiplied them.
Oh, wait, yeah.
So you can combine them by adding them. So it would be 5x plus 3. Negative 2 and 7 would give us 5. 6 plus negative 5 is a 1. And then the negative 4 minus y. Did anybody else add those together first? A couple of you? So if you didn't add them together first, Aaron, what did you do first?
Me?
Yeah. Oh, you did add them together first? Sorry, I didn't see that. So who else did it a different way besides adding them together first? Chris, what'd you do? So another thing that you could do instead of keeping the 3 out, or instead of multiplying everything by 3, you could divide by 3. And I'm going to do that in this step. You didn't have to do that at this point. You could have, I think a lot of people multiplied everything by 3 inside, which is okay, because that definitely works. It just kind of depends on what you see. So, Chris, if you divided by 3, how did this matrix change?
-7, 5, 1,
Right. So again, if yours is slightly different, that's okay. So if you took the 3 through and made this a 15x, your answers are just slightly different. You might have 15x plus 5 here, and then a 15 and a 3 and a negative 12 minus 3y. So it's okay if you did something different first. How do you actually solve for x and y? We combined the matrices together, we got rid of the 3, but we still need to find x and y. How do we find x and y? Lauren, do you have an idea?
Well, the top left is equal to like 5x plus 3 is going to be equal to negative 7. So then you would do 5x plus 3. And then minus 3.
So minus 3 is negative 10, so x is
Negative 2.
negative 2.
And then same for y, you just do negative 4 times y equals negative 8. And then negative, or y, equals 4.
Good. So if you notice in the matrix, the 5 matches up with the 5. or maybe you have a 15 here matching up with a 15. Your 1 bottom right or left matches up with the 1, or again, you might have a 3 here if you multiply by 3 matching up with a 3. So with matrices, if there's an equal sign, then the elements that correspond must be the same on both sides of the equation. So you can use that fact, as Lauren did, and take the portion that corresponds with the number on the right side of the equation and set them equal to each other. Just checking your work, if I plug in a -2, I have -10 plus 3, which is -7. And down here, if I plug in a 4, -4 minus 4 does also make -8. If you did it differently, does anybody have a question as to where if you made a mistake, you didn't get the same answer, I can come around and help. So if you might have done something a little differently, that's okay. As long as you're working through and correctly multiplying, dividing, you should still end up with the same answer. So there are 3 problems left, really short day of notes. These 3 problems, again, I don't know why some of the matrices came out differently than others. But these are matrix boxes here, brackets. That second matrix you're multiplying by -3, that's the scalar. That's a 2 by 4 matrix. So see if you can do those last 3 problems. For number 3, trying to decide which way is best for you to solve that equation. Jacob, what did you get for the first one?
-9, 2, -8,
Jacob Smith, how about number 2?
-3, -9, 6, -12, -6, -27, 18, 0.
Any questions with the first 2? So then the third problem, kind of up to you how you want to start it. But there is that -2 there, so whether you choose to multiply the -2 through or divide it out of the problem is your choice. To me, dividing it creates smaller numbers. So if I divide it right away, on the right side, I now have a -6, a -5, a -1, and a +9. So I got all my numbers in half on the right side instead of on the left side, doubling all of the numbers. What else would we do? So if I divided first by 2, what would we do next then?
You'd add the -3x 1 plus the 9 and
Okay, so -3x plus 9, and then
-5,
-5,
-1,
-1, and
plus
good. If you can do that in one step, that saves you a whole bunch of writing the matrix another extra time. So in the first kind of one line here, I divided by -2, and I added the stuff together on the left side. So pairing our information, making sure that things correspond, we have -3x plus 9 equals -6, and y plus 3 is +9. So Zach, what are the 2 solutions, x and y?
equals 5 and y equals 6.
Good, and y equals 6. These are not ordered pairs. Don't write them together as an ordered pair. So x represents just the x variable in here, the y is the y variable. It's not a system of equations that we're solving for. Questions? So you have 10 minutes. I have 2 books up here. Here's another book. There's 3 books over there. Feel free to take a picture of the book, start working, or actually grab a book off the shelf over there. You can grab this one up here on my desk. But you've got 10 minutes to get started on your homework. So please get a piece of paper, take a picture with your iPad, your phone. Get a picture of those pages.